All right, so we have two triangles here, ABC and DEF. And if you notice, you'll see that the line segment AB from A to B is 3.6, and that seems to be congruent with my line segment DE. Also, notice that angle A is congruent to angle D and that AC is congruent to DF. And so we're going to prove congruence having only a side, an angle, and a side, an angle, and a side by doing rigid transformations. So first thing I'm going to do is I'm going to take my triangle ABC and translate it so that point A matches up or maps to point D. And so just so we can keep track, I'm going to change the color because we're going to do a couple of transformations. So the greens are original ABC, and then we'll change this to pinkish, and that's going to be A prime, B prime, C prime. And so now what we're going to do is we're going to rotate this new triangle about the points A and D 180 degrees. So I'm going to rotate that. So let me select transformations. So I'm going to rotate this triangle about this point 180 degrees. The next thing that I'm going to do is I'm going to reflect this triangle over the line segment AC. So before I do that, let me change the color. We'll change it back to red, or we'll just leave it red. And I'm going to rotate that about AC. So I'm just going to flip this on top of the other triangle up top here, just like that. And if they are congruent, then they will match. So they did match, and as you can see that I was able to map triangle ABC onto DEF. And that's the proof.